In this video, we're going to talk about the mole and what a mole is by definition, and then how we can use it to compare different things. So a mole is a unit of measure that tells you the number of particles, and a mole is a set number of particles. So a mole is a number of particles. And that number is specifically 6.022 times 10 to the 23rd. That's a lot of particles. So a mole is this huge quantity. And we can use this word just like we use the word dozen. If I tell you that I brought in a dozen donuts, how many donuts do I have? Well, I have 12, because we know that the word dozen means 12. The same thing goes with a mole. When I say I have a mole of donuts, that means I have 6.022 times 10 to the 23rd donuts, which is a lot of donuts. So these two things are used interchangeably, just like a dozen is used interchangeably with the number 12. So it refers to a set number of particles. We also use it as a unit. So we can say we have 0.2 moles of something. That means we would have 0.2 of 6.022 times 10 to the 23rd if we have 0.2 moles. So we're going to see this as two different things. We're going to see it referring to the number. We're also going to see it as a unit referring to the number. So let's do some comparisons, and we're going to start with some simple ones. So if I were to say 12 bricks versus 12 feathers, we want to compare the amount or the number versus the mass. Now, which of these are there more number of the objects? Well, we have 12 bricks and 12 feathers, so it's the same amount. So that means the same number, because it tells us that we have 12 of them. But which is more massive, a brick or a feather? Well, a brick is substantially more massive. So the bricks are going to have a greater mass than the feathers, because even though we have the same number of them, each brick is more massive than each feather. So bricks are more massive. What if I looked at masses instead of numbers? If I compared 12 kilograms of bricks to 12 kilograms of feathers, well, since the number I'm given is in kilograms, and we know that's a unit for mass, we have the same mass of the two. So we have the same mass, because it tells us we have 12 kilograms of bricks and 12 kilograms of feathers. If we were to put them on a balance, they'd equal each other out. However, if we were to compare numbers, still bricks are more massive. So to get the same number of mass, we'd need a lot more feathers than bricks, because the feathers are much lighter. So it's going to take more to get to 12 kilograms. So we have more number of feathers. So because we know what the individual mass is, roughly, we just know that a brick is a lot more massive than a feather. We know that if we have 12 kilograms of each of them, we're going to have way more numbers of feathers than bricks, because the feathers have a lower mass than the bricks. Now, if we wanted to compare actual elements instead of just bricks and feathers, because bricks and feathers aren't very useful for chemistry class, what we do need to compare are individual elements. And to do this, we're going to use a number on our periodic table. So on our periodic table, there's a box for each element. And on the bottom, there are several numbers in this box. So on our periodic tables, the name is at the top of the box. The number below that is called the atomic number. We're going to get to that later. The symbol is below that, and then the number at the very bottom is the mass. So I'm going to hold this up closer so that you can see it. So the name is at the top, then we have the atomic number. Like I said, we'll talk about that later. Then the symbol for the element, and then at the bottom is a number in decimals. That number tells you the mass of an individual atom of that element or an individual particle of that element. It also tells you the mass of 1 mole of that element. So if we look at carbon, the number that's at the bottom of carbon is 12.011. That tells me that 1 atom of carbon has a mass of 12.011 atomic mass units, or AMUs. That also tells me that 1 mole of carbon has a mass of 12.011 grams. So that number means 2 things, but regardless, it's always referring to the mass. It's either the mass of 1 atom or the mass of 1 mole. So let's use this to compare. If I have 1 mole of carbon and 1 mole of phosphorus, well, a mole tells me that I have 6.022 times 10 to the 23rd. So I have 6.022 times 10 to the 23rd carbon atoms, and I have 6.022 times 10 to the 23rd phosphorus atoms. So we have the same number, or the same amount of particles. But if I look on my periodic table, a mole of carbon has a mass of 12.011 grams. A mole of phosphorus has a mass of 30.974 grams, which means my phosphorus is going to be more massive. So even if I have a pile of carbon atoms and a pile of phosphorus atoms, and even if they're the same number, if I were to mass them, my phosphorus is going to have a greater mass than my carbon because my phosphorus atoms are more massive. If I compare 1 gram of carbon to 1 gram of phosphorus, these guys have the same mass because it tells me 1 gram and 1 gram. So if I were to put them on a balance, they'd have the same mass. However, if I go back to this information, my phosphorus atoms have a mass of 30.974. My carbon atoms have a mass of 12.011, which means in my 1 gram, I'm going to have a lot more carbon than phosphorus because my carbon are less massive than my phosphorus. So to get to the same mass, I need more carbon. So I'm going to have more number of carbon, oops, that's a C, because my carbons are less massive. So if you're comparing equal masses and you're trying to go to number, it's your less massive individual object that's going to have more to equal the same total mass. Now, I know this topic is extremely confusing. It makes my head hurt just as much as yours. We're going to put this to some practical use, but you do need to know the basics of when I say a mole of something, what that means. And so it's different. A mole refers to the amount, not the mass. Those are 2 different things, and that's going to be very important in the future.